Yeah, so in the last lecture we have seen some videos which are there in our laboratory, and then we will just continue this class also for the revision of all those equipments one by one, so that it will be useful for us. So this is again a jaw crusher, which is a primary crusher. So this is the driver pulley, and this is the flywheel, and these are the hardened jaws where we put the feed from here. So see the two hardened jaws which are having corrugations to increase the friction, and from here we can see the V shape, and then this is pivoted at the top, so hence it is called as the blade type of jaw crusher. So here we have a maximum opening at the bottom, so this V shape, so we put them stones here and the crushing will take place from the bottom, it will be coming out. So an electrical motor again here is used to drive the motor by means of this pulley, and here see the gaps are there because I said that we are supposed to see that the tension is created inside this belt, okay, by adjusting this motor. So so that we can see that the entire power is transmitted to this particular motor. Now see the size of the particle is putting. That is important, and these are two guides, okay, sideways, so that the spillage will not be there in the other side. But of course, this we didn't have in our lab or in the diagram which we have seen. But commercially, we can keep them so that here also these hard faces are hardened one. See from here how the particles are falling down, and you know the sizes of the particles are different. There is a variation there between the smallest particle and the larger particle. And the most important thing which you should observe is what, once you do sieving here, what will happen, majority of the particle will be there on the topmost sieve, and in the bottom we will have less amount of solid. That is the characteristic of a primary crusher, where majority of the feed will be there in the top screen and less amount of the particles will be falling into the pan. And as we try to go down, what will happen, majority of the particles will be accumulated inside the pan, and in the top one there will be minimum or negligible solid particles will be present. See, we are giving some time, that is important. See, here in the industry, they may not be having importance of power consumption, but once we charge the material, we are supposed to wait till the entire crushing takes place. And as the particle comes out, and remember it is visible to us, we can see how the crushing is taking place. And once in between the V shape, the solid is falling down, there is no solid is there, then we can add the second solid particle, and thus the crushing takes place. I said that in our lab, m dot is very important because in Rittinger's law or in Kick's law or in the Bond's law, we have in the denominator m dot. So if you try to increase the m dot, the power consumption, lot of variations is there. So how you are going to put the feed is important. So once you drop the solid particle, you will be hearing the crushing noise is taking place. Yesterday you have seen in the video that huge noise was there as the machine is running. So when you are putting the solid particle, you can imagine how much amount of solid, how much amount of noise it will be emanating. So once you hear the noise is coming down, then of course you can try to add the second one to this material, and like that manually, that is our art where we can control the values of m dot. The second particle is added. third particle is added. So now you can see once we add the particle where it was initially at this point because its size was very big. But as the phases are coming together, what is happening, sir? The crushing is taking place and the size of the particle is decreasing. When the size of the particle decreases, it falls down because of the gravity. So now the jaws should come together to apply force on the particle. That is the significance of V shape in this size reduction equipment. Please remember this. And as the particle crushes to a small size which can pass through the narrow opening of the end of the jaws, the particle discharges from the jaw crusher. Yeah, now see all the particles have gone out because their sizes were able to pass from the bottom. And here one more thing you should observe is what this is a blade type of a jaw crusher where the pivot is at the top and maximum clearance opening, that is variation of the discharge, is there at the bottom. So hence this will not choke the solid particle, whereas the Dodge one, if you take it, that is pivoted at the bottom. So here you have a maximum variation. So when this jaw is going back, and if any heavier particle is sitting, that it may not come into the back because as the size of the particle is more, we require more amount of force to break it. So Dodge is a failure model. So the modification of Dodge is a blade type of jaw crusher. Here the pivot will be at the top and the maximum clearance is at the bottom. But here what is the restrictions are? If the particle is able to pass through this gap only that particle only we can add to this jaw crusher. That is the limitation of a blade type of a jaw crusher. Please try to understand this. So these are the crushed product. Again the lump is added. Okay, I think this is enough for us. Then we'll go to the animated part of this. Sorry. Animated part of the jaw crusher, which I got it from YouTube only. Yes, this is the pivot at the top and the maximum movement is at the bottom. So the solid particles are charged from here, the V shape, okay. And as the particle is decreasing, we are supposed to catch the particle. So now they are entering into a zone where the area is less, so that we can nip the particle and then we apply the compressive forces and the particle will be broken. And eccentric creates a motion for this. If you see the tip of this blade, what is the motion which is generated is because of the eccentric, which are not concentric to each other. Then I had another video for so the disadvantage of the blade type of jaw crusher is that though it is rotating at 250 to 400 gyrations per minute, at any instant of time when the swinging jaw is moving away from the fixed jaw, crushing will not take place. So this kind of problem is removed in this one, where we use a shaft on which a grinding roller is there, which is free to rotate also. And in this V shape, where internally the lines show the corrugations of the hardened material, and once you try to draw the solid particle here, what will happen when this goes in this direction, crushing will take place. When this is going away from here, the crushing will take place in this particular chamber, so that at any instant of time the crushing will take place in this directive pressure. Yes. So now let us have a quick revision of so basically, if you see, these are the size reduction equipments which are available to us. Okay, 1 second. Yeah, now it is this. So these are basically the size reduction equipments classifications which we are supposed to study. This may be a 4-mark question. So first we'll have the crushers, then we have grinders, then we have ultrafine grinders, and then the last one is the cutting machines. So we know that the solids are broken by means of applying compressive force. We can apply the impact on it. We can apply attrition forces, and finally, the size of the particle can be reduced by means of cutting actions. So application of compressive forces, the primary example is the crushers. And impact means what? Application of huge amount of force or large amount of force on a particle for a shorter duration. This we have seen in the ball mill. Similarly, attrition mill, where two discs are there. Yesterday we have seen this also, where two discs are there. One disc may be rotating, may not be rotating, whereas the other one should compulsorily rotate. And as they are rotating, we introduce the particle in between, and as they pass out from the bottom, they will come in contact with the narrow gap which is there in the disc. So because of it, the shear forces will be applied on the object, and then the size reduction takes place and it passes out from the bottom. And the last one is, of course, the knife cutter, where specific sizes we are going to give it to the particles, especially when we are using leather type of materials or plastic materials. We are supposed to pre-chill the feed because there will be elongation will be there, and after the pre-chilling, what will happen? The material will attain a property of brittleness, and thus the size reduction is possible. So in a nutshell, these are the 4 methods by which we can reduce the size of the particles. So the first one is the crushers, coarse and the fine. So if you see the crushers, they will be doing heavy duty. They will be accepting feed of larger sizes, which can be measured in terms of millimeters or in inches. So bigger size particles directly which we obtain from the ore are sent to the crusher, or we can also say that near the ore only we have a primary crushers, because transportation will be easy for us when the size of the particle decreases. So a primary crusher will accept the feed of coarser in size and then crushes it to particles of very small sizes in the due course of time. We can also get fine particles, but these fine particles are of no use for us because now we can send it to the secondary crusher. So the examples which are there for us is jaw crusher, gyratory crusher, and then crushing rolls. So these are the names of the equipments which will fall under the category of crushers. Then the grinders. So whatever the feed is obtained from the crusher, it will now send to the grinders, because our aim is to crush an ore particles to a very small sizes. For this purpose, we don't have a single equipment in there. We have to have a hierarchy of size reduction equipment which are operating on this particle in a series manner, on a cyclic manner, so that ultimately the coarser particles are reduced to the particles whose sizes are measured in millimeters per gram, or nanometers, or screen sizes. Whatever the size is demanded by the customer, there we are going to stop it. Then we have the grinders, where they will be doing the intermediate and the fines. Again, the fines are obtained. Why fines are there? Because remember, we are dealing with heterogeneous materials, and when we apply the force on the heterogeneous particle, and at the same time the concentration of active mass in the line of application of force is also very important. So if it is not there, then the particle breaks into n number of particles, and in the due course of time, we can have very small particle can also be obtained. So if you see the videos, what has happened is we are putting lumps, but we are getting even small particles also. But lumps are more, fine particles are less. So this is the character of the machine. In the grinders, of course, we have hammer mills, impactors, rolling compression mills. Example is ball mill, roller mill, attrition mill, tumbling mills, rod mills, ball mills, pebble mills, tube mills, and compartment mills. So the classifications are given, but only the highlights are there for few items only, which we have discussed. Then ultrafine grinders, the feed from the product which is obtained from the grinder is now sent to the ultrafine grinders for further crushing to take place, where the size of the particle will be very much reduced to nanometers or millimeters per gram, depending upon the energy consumed for the process. Hammer mills, fluidized energy mills, and agitated mills. And finally, the last one is the knife cutters, where the rotary knife cutter is used, where flying knives are there, which will be reducing the size of the particle of perfect size. Perfect size is obtained by using a knife cutter. Now, this is the diagram which you are supposed to draw in the examination. So we will have the names written here, that is eccentric, pitman, flywheel, spring, toggles, discharge, stationary jaw, hardened jaw faces, swinging jaw, and then the pivot. So the first one, if you see it, the most important thing for us is this is the heart of the machine, where two jaws are there, hardened faces are there. Why? Because these faces will be using compressive forces acted upon them by the machine, and directly they will be dealing with the solid particles. And solid particles are irregular particles, they may have sharp edges. So when they have sharp edges, there is a chances of damaging the faces of the jaw crusher. So hence, to avoid that, let us make the faces of the jaw crusher by means of a hardest material. Generally stones are used or graphites are used for this purpose. And to increase the friction, we have corrugations of different fashions. That is important. So in our laboratory, if you see, we have squares were there. Now the today's experiment, if you have seen, we have seen crescent troughs were there, long one. So it all depends upon the design part. But prime aim is what? Prime aim is to increase the friction, induce the friction, so that we can particularly catch or nip the particle and then apply the compressive forces and reduce the size of the particle. That is our prime aim. What is the fashion? It is depend upon the designing of the machine. Then the second one is we have two jaws. The first jaw is called a stationary jaw, which is mounted to the casing of the machine, which is not at all moving. But the second one is now free to move. At the top one, it is pivot, means what? It is fixed at the top one. Fixed means what? It is not stationary, it is moving. So it is having a reciprocal, it is having a swinging motion. So this is obtained by means of pivot joint. So what is the pivot joint? I told that for a bicycle, we have a pedal, and the pedal is connected to a steel rod, and the steel rod is connected to the shaft. So the connection between the shaft and the steel rod is the pivot joint. So that with the help of your pedal, you can swing it left hand side to right, or any side you can swing it in one particular direction only. That motion is important for me, because here the jaws, they have to come near, they have to go away. They have to come near, they have to go away. So this kind of motion can be obtained by this pivot joint, and from the bottom it is connected to the eccentric of the system, so that in this eccentric what will happen, sir, this is the central shaft which is connected to the machine, and this is the flywheel, and this pitman is little bit connected separately, not at the center. We give some clearance to it, and then so when the shaft is rotating, what will happen, this will be moving in this eccentric manner, and that eccentric manner will create a motion for this particular tip. If you observe this tip, this has to go back and come this side, go back, come this side. So this is guided by means of the toggle. Now toggles will provide the backward force, because if the force of the size of the particle is more, what will happen? Then this may not go beyond this. So hence we are supposed to support it from the back. So these toggle plates are also very important, which will be giving support from the backward. And then once you put the particle, what will happen? Here the V shape, already told you that as the size of the particle is decreasing, we are supposed to see that the crushing surfaces should come near to the object whose size is less. For that purpose, V shape is important. And here we have a maximum variation there. Because of it, what will happen? If we say that if the jaw is coming to the stationary jaw and the clear opening is 1 millimeter, when it goes back, it is 5 millimeter. So there is a variation is there. 5 millimeter particle can also go, 1 millimeter particle can also go. So hence we are giving more room for the solid particles to go from the crushing zone. Thus there is no problem of choking is there for this Blake type of jaw crusher. So here Blake means what? The pivot is at the top. If pivot is at the bottom, it is called as Dodge type of jaw crusher. So these type of jaw crushers will not be subjected for the choking, provided as the solid particles are falling from the bottom. With the help of a conveyor belt, you take out the product from here, or else what will happen, the accumulation of solid particles like a pile, it enters and it may enter the geometry or it may enter the size direction equipment, and then it will not allow the solid particles to come inside. So to avoid that, this is very important. That is, we see this topic in the mill discharge. So as the particles are crushed, they are falling on a conveyor belt. Immediately they should be taken out from the place so that it will give a room for the second particle to come and fall onto the conveyor belt. That is very important. And unfortunately, if a foreign material, that is material whose compressive strength is very high, if it is falling in between, of course generally the operator has to take care to eliminate this kind of materials. But unfortunately, if it happens, then what will happen? This connecting rod will go back and the relief spring will be open and the jaw will not operate. It will go back and then the particle will fall because of the gravity. Then this distance and the bottom distance will be same. Then the particle will be thrown out, and that indicates that there is a problem is there in the machine. The operator then he will stop the machine and then he will release the spring. Again the functioning will take place. During the due course of time where the energy will be stored in your flywheel. So flywheel is, what is the significance of it? When the machine is not using the power, then the given power will be stored inside the flywheel. As in the crossroads, you will not stop your vehicle, you will catch the clutch. So when you catch the clutch, what will happen? Energy will be stored into the flywheel, but the piston is burning the petrol. Okay, so that the damage is not there for the machine. So this is the diagram of a, what do you say, the Blake type of jaw crusher, which will definitely come in the examination. So you are supposed to draw this and then explain it as we have seen in the previous classes. Then of course this is the diagram of a gyratory crusher whose video we have seen in the morning. So here we have a feed and then we have a spider arm. We will open this nut and then this will be moving from here. It can swing and then we can add the feed particles to it, and once you start the machine, what will happen? The main electrical part will be at the bottom one, where the top one we are having to have a bearing which is not moving. Okay, so this will facilitate the rotation of this shaft. Okay, and then we can revolve it. So we have an power, we have a pulley here. So once we drive the pulley by means of external motor, this shaft will rotate, and this shaft, when it is rotating, what will happen? Here we have a gear, so we will be converting this motion, and then this will be starting in this particular eccentric fashion that will be moving. So here also we have a conical concave type of container where inside it is having the liners. So this is made up of a stainless steel or cast iron, but inside we are going to have the liners of the graphite or the stone, which are having corrugations to increase the friction. And this shaft will also carry a crushing head which is rotating. Remember this, that is also rotating on the free shaft. So what is the significance of it? Once you add a feed, what will happen? This may be coming this side. So if you see this diagram, we have a minimum opening this, that indicate that the crushing head is towards this concave. And since the crushing head is towards this concave, we will have a maximum discharge at this point. And the next cycle, what will happen? The crushing head will move towards this concave. So here we have a minimum opening, here we have a maximum opening. So unfortunately, if a heavier particle is falling, what will happen? The compressive strength given by this machine may not be sufficient to break it. In that case, of course, the shear forces, because now this will start rotating, isn't it? Because of the slip, it will start rotating. This concave is not rotating. So hence, one is rotating, another is not rotating. So hence, shear forces will be there to reduce the size of the particle. Once the size of the particle reduces, its compressive strength will become small because the mass is less, and hence the compression takes place. It falls from the bottom. From the discharge, we can take it out. So the disadvantage is what in the previous one, the Blake type of jaw crusher, continuously the product may not be coming out, but that problem is removed by means of this new design called as gyratory crusher. And here we have the gyratory crusher which is continuously giving the feed from the bottom. Okay, and since of this intricacy of drawing the diagram in the examination, rarely this question will come in the examination. Yeah. So this is about the smooth roll crusher, where there are two rolls are present. Yesterday we have seen the video also. And remember, the width of the face is important. So two roll crushers which are made up of a stainless steel shaft, but of course it will be carrying cylindrical crushing medium. Okay, cylindrical crushing medium is put on the shaft, and then they will be rotating. So if this shaft is rotating in the clockwise direction, this will be rotating in the anti-clockwise direction. And here we try to bring them by means of the springs. Of course, in our lab we don't have this provision. So here we are in the industry, we have this springs are there. Because of this spring action, what will happen? This entire system will move in this direction, and because of this spring action, this entire system will move in this direction. Means what? We are inducing some tension in between the crushing roll. That is the significance of keeping the relief spring. And then what will happen? Once you charge the feed, what will happen? Since the feed is a irregular particle whose shapes and sizes are very not clear to define, but one thing, that the feed is of same uniform size. So hence we can say d bar SA is constant. So once we add the feed, what will happen? The first step is angle of nipping, or nipping is important. The process of catching the particle by means of these rolls, and then after catching it, this particle will be drawn out by the machine through the narrow gap. Because of it, the suddenly compressive forces will be applied on the particle, and the particle breaks into pieces, and from the bottom it comes and falls out. That is the end of the story. Unfortunately, if a material of high compressive strength enters, no need to panic. So these two rolls will go back because they are not able to come this side because of this heavier particle. Then the particle will be thrown out. In the due course of time, the energy will be stored inside the flywheel. And then there is no need to readjust it, because in the Blake type of jaw crusher, the operator has to release the spring. That problem is not there in this relief spring. Automatically, again, once the particle is going out from the system, the second process of continuation will take place. So this is the example of a smooth roll crusher. And this is example of a single roll toothed crusher. So here we have a shaft. On the shaft we have a disc, and the disc will be carrying the teeth. A gear will be having a teeth. Remember this. Okay, but here the teeth are of different sizes because we wanted to tear the feed and then reduce the size by means of applying some force on a different plate. So the different plate is a wear plate here, and this is also having a lining of graphite or stone, which is again having a friction. So here what happened? This is in the curved path, and then once you add a feed of different size, what will happen? This sharp, this is the one teeth, this is the second teeth, this is the third teeth. So this is a one item. Then the second one, the second item, the first teeth, second teeth, third teeth. This is the third item. So like that, these elements are present on the disc. And once you rotate, what will happen? The sharp corners will drag the solid particles through a narrow opening. And since this is having a high surface resistance, wear resistance, the particle is dragged into the narrow opening, and thus the side direction takes place and it falls from the bottom. There is no question of choking or anything else. So this will be forcibly drawing the material, and they will be coming out from the system. Okay. And here also the flywheel, if at all any crushing is not taking place, then of course the operator has to reduce in the reverse direction and then remove the solid particles from the top. So remember, the prime important thing is feed is important. We should not admit the feed of different sizes, or whatever the design size is given to us, only that one has to be sent. And what type of nature of the material we are sending, that is also very important. So if you take care of these 2 points, the jaw crushers or any type of crushers will be successfully functioning without any interruption. So this is the example of a impactor mill where a shaft is present, and this shaft will be carrying the beaters, or nothing but what is the beater, sir? A heavy solid mass, consolidated mass is connected to this disc, and once this disc is rotating, so this beater will be thrown out because of centrifugal forces, but they don't go out because of this pivot joint. And then since same pivoted beater, pivot joint, and as they rotate, what will happen? The feed enters from here. When the feed enters from here, that will be taking the blow of this beater, and that will be moving. So there only side direction takes place, and then the remaining part, the particles which are formed, they will be moving with the tangential direction. They go away from the center and they will be striking these anvil plates, which are also having liners on their surface. And again, because of the secondary impact, the solid will be reduced, size of the solid will be reduced, and from the bottom they comes out. Okay, this is about the impact mill. The previous one, all the mills were functioning on the compressive forces, whereas this one will be functioning on the impact mill. Then this is example of an attrition mill where the two discs are there. This is the disc number 1, this is the disc number 2, and where we have a gap in between this gap to facilitate the admittance of the feed. The feed will be falling. So this is not rotating. This is mounted to the shell or the casing of the system, whereas the another disc whichever is there, that is mounted on the shaft, and the shaft is connected to an electrical motor which is driven. Okay, and the clearance between these two discs can be altered by means of this screw. Yesterday I have shown you this also. So if you want to have a product of very small sizes, then rotate this in the clockwise direction. If you want to have sizes not so small sizes, then of course rotate in the anti-clockwise direction, so that the clearance between these two will be altered. And once you admit the feed from here, it falls at the center because we have some free space here, volume here, because of this increase in this area. So the material will fall from here, and because of gravity it falls down. As they are falling, what will happen? The area is decreasing, and then it has to pass through the disc. One disc is not moving, another disc is moving. So hence there will be shear forces will be there, which are acting on the surface area of the solid particle, and thus the side direction takes place and it falls from the bottom. So attrition mill, the mode of side direction is shear forces, which are applied by means of these two discs. One disc is not rotating, other disc is rotating. So this is about the attrition mill. And this is the ball mill, which is also very important, because whatever the diagrams are easy to draw, they will be asked in the examination. And since ball mill is there, a separate experiment for us, so this question is also very important. So this ball mill basically consisting of 3 parts, but in the laboratory yesterday we have seen only one part was there, that is cylindrical part, because it is a prototype of ball mill, which is a small ball mill. Okay, so hence imagining of these two converging part and diverging part is not there. We have only cylindrical part is there. But in case of a cement industry, if you see, they have a very big ball mills where we can accommodate one classroom easily in that ball mill. Cement industries will have very big ball mills. So here it is basically consisting of 3 parts. The first one is the diverging part, the second one is the cylindrical portion, the next one is the converging portion. The length of the converging portion should be more than that of the diverging part. So in the diverging part, what happens is that the angle is very steep, so that as soon as the feed enters, it enters immediately to the crushing zone. And here the crushing will be taking place because of the grinding medium, which are spherical stainless steel balls. We can use pebbles. It will be called as a pebble mill. We can, if you are using a rods, then it is called as a rod mill. Then we have slightly modified the diagram. So we should have the more amount of cylindrical part. And in case of a tube mill also, we should have the cylindrical part should be length. So depending upon the compressive strength of the material, we can go from rod mill, we can go to the tube mill, and then finally to the ball mill. Okay, so initially the size of the particle is more, so since its mass is more, so we require a bigger sized particles to break the size of the material. So once the size of the material, because this entire ball mill will be rotating by means of an external gear which is mounted on it. So here we have an external mounted gear which is driven by means of an electric motor separately. They are present on a foundation which are having bearings, and this type of discharge is called as Funian discharge. We'll see in the later section. So we open the manhole and then we add all the solid particles. So ball mill can be operating on the basis of batch process or in a continuous process. So suppose if it is a batch process, we will open the manhole and then we charge the material, we'll close the manhole and we'll start the ball mill. So ball mill will be rotating slightly less than the critical speed, because if it rotates above the critical speed, the process of centrifuging will take place, which is a very bad thing where the crushing will not take place. So once you add the feed from here, it enters the zone of the crushing medium. The spherical bars will be lifted and they will be made to fall from the top. So when they are moving along the diameter, the longest cord, they travel to a greater distance and their velocity becomes more. And once they fall on a particle, the particle breaks into pieces. So this is how the crushing is taking place, and the mode of crushing is because of the impact. Now, the why we are going to reduce the size of the ball, because as the particle size decreases, it is a chance there that it may hide in between the gaps or the wide fractions of the larger spherical balls. So to avoid that, if you replace these higher spherical balls by smaller balls, the wide fractions will be reduced. At the same time, since the size of the particles are decreasing, why you want to expand this much amount of larger spherical ball for breaking that? So we can use a smaller ball, smaller balls also, whose sizes are small. So one more factor will be why this converging nozzles length is more, because that also important, because as you know the size of the particle is decreases, what will happen? The diameter of the particle is decreasing, so hence the centrifugal force experience will be less. So it may be concentrated along the walls of the container. So we will see in the next slide that if you have this kind of converging nozzle which are having more length, then what will happen? The denominator will decrease and we can induce some centrifugal force on the particle which goes away from the center, and then it falls. It will be some particles, some grinding medium will fall on it and the crushing will take place. And as long as the particle is passing through this conical grate, then till then the particle will be present inside the ball mill taking the blows of the grinding medium. Once the size is less because of the displacement, it goes out from here, it falls from this particular plate. So this conical grate will be preventing the spherical balls to fall to coming out from the system. Yesterday, if you see our ball mill, there is no conical grate over there. Because of it, the spherical balls are falling down. Because ours is a small ball mill whose capacity is only 1/2 liter, we don't have much problem. But in industry, we cannot even imagine of replacing the spherical balls into the grinding medium. And in some type of grinding ball mills, what will happen? There is a segregation partition will be there, where the balls will not move from one particular zone to other particular zone. Means what? These spherical balls will not come to this one because of the segmented brackets, which will prevent the particles, the grinding medium to move. If they try to come here, what will happen? Crushing will not take place in particular zone. To avoid that, we try to confine them in particular compartments. And the next thing which we have seen is we can also pour water into the ball mill, provided what is the main purpose of it? We are supposed to displace the solid particles and then bring it to the vicinity of size reduction zone. Keeping this as a fact, if you pour more amount of the water, what will happen? The spherical balls will first strike the surface of the liquid, then they travel in the liquid medium to hit the particle. So there, the energy losses are there. So loading of water is very important factor in the ball mill. So here we have a proof also where we have seen in the theory part, derive the critical speed of a ball mill. So we should state that first point, a ball mill will have a cylindrical portion which is given by the circle, and the radius of the cylindrical portion is given by capital R. And then initially the spherical grinding medium will be at this point whose radius is smaller. Capital R is the radius of the ball mill and small r is the radius of the particle the radius of the grinding medium or the particle, whatever it is, whose size reduction has to be taking place. Then what will happen? The grinding medium is initially at this point. So there in our laboratory we have the baffles for there, which are the facilitators for lifting the solid particles, but here it is not shown. So here we'll assume that the spherical ball at the grinding medium will be at this point initially, and once the ball will start its RPM slowly, what will happen? The spherical ball will rise from here and then it falls back. Again it rises, again it falls back. Again it rises, it falls back. So as you go on increasing the RPM, what will happen? A stage will come that the grinding medium, I repeat, the grinding medium rises to a maximum this height, and there from here this point we are supposed to break the contact. The contact is broken when the gravitational force becomes slightly greater than the centrifugal force, and thus in this maximum length it falls on the object. If an object is present, that will be taking the blow of impact and then the side direction will take place. So the speed at which this is rotating is called the critical speed. So the critical ball mill should slightly rotate less than the critical speed, not at 100%, 99.9999 or 0.9% of the critical speed. It should rotate. So once this happens, what will happen? The crushing will take place. Suppose if you violate this, if you increase the RPM of the ball mill, what will happen? the point of contact will not break because the centrifugal force will be exceeding the gravitational force along acting on this line, and then what will happen, the grinding medium will be staying away from the center, which will be concentrated along the walls of the container, but the spherical ball will be moving, but no crushing will take place. This is called as centrifuging. So centrifuging is a big question. It occurs when the ball mill rotates above the critical speed. So slightly below the critical speed, if it is rotating, then of course the crushing will take place. Okay. So this diagram is there. So you know the mass of the small grinding wheel is given by m. So if this is making an angle alpha with the vertical, first point is the force of gravity always acts in the downward direction. So we know F is equal to mg by gc. So force of gravity is given by this mg by gc. Then suppose if I resolve in this direction, then you will have mg by gc cos alpha. So these are the two opposing forces. One force acting in the center, towards the center, one force which is acting away from the center. That is the centrifugal force mu square r by gc. What is r, sir? R is the distance between center of the ball mill and the center of the particle. So r is the radius of the ball mill given by r. So here you have a grinding medium whose radius is smaller. So I want this center and this center. So capital R minus small r will become the denominator. So how to increase this centrifugal force? Because mass of the particles, we cannot do anything with it, because the ball mill is uniformly rotating with the critical speed, you cannot alter it. So how can we induce the centrifugal force? The only method is r minus small r. So if you remember the previous slide, as we are going from left hand side to right hand side, the converging part, the length is more uniformly. Why? Because as the r is decreasing, the converging part is decreasing, what will happen? This value will decrease. When this value is decreasing, the fraction value will increase. Thus the centrifugal force is increased. That is the purpose of it. So in the converging part, what we are making an attempt is, we are increasing the centrifugal force of small particles so that it tries to go away from the center, and then it takes the blow of a grinding medium from a greater distance when it falls from a greater height, and then the side direction takes place successfully for that particle also. So that is the concept behind it. So if you try to equate these two, and then you will get the formula for the critical speed of a ball mill, which is given by the formula 1 by 2 pi square root of g divided by capital R minus small r. Okay, so this proof is also they will ask in the examination. Yeah, so if you see this, yeah, so we will equate this mg by gc cos alpha. So cos alpha, if you take this, sorry, this I think the material has gone away, I'll write it. So cos alpha can modify this equation, so mm will get cancelled, you finally get g. So at the critical speed, alpha will become 0. Why alpha will become 0? Because the spherical ball will reach the topmost level. So when it reaches the topmost level, alpha value will be decreased to 0. So cos 0 is 1. So thus at this speed, n becomes nc. So when alpha is equal to 0, cos alpha is 1, n will become nc. nc is the critical speed, which is given by this formula. And finally, the tumbling wheels run at 65 to 80% of the critical speed, not above this. Because remember, we are having spherical balls of different sizes. So we should count all those spherical balls, measure their diameters, take the average diameter divided by 2. That is how we are getting to get the value of small r. Remember this. Whereas the value of capital R will be given to you. Small r, of course, we are supposed to measure it and then write it. G we know, and that is how we are going to find the critical speed of the ball mill. I repeat once again, the value of capital R, that is the radius of the ball mill, will be given to you. So you have a spherical balls, take the vernier calipers, measure the diameters, how many spherical balls you are going to put it, that is there in your hand. You count them and then measure the diameters, take the average of it, divide it by 2. This is how you are going to get the value of small r. So this is how we are going to find the formula, that is for finding the critical speed of the ball mill. So this is another example of a micro atomizer. This is also very important from the examination point of view. So here basically the concept is, after the size reduction is over, we are going to use the air for the transportation of fine particles from the system. So on a continuous basis, this is done. I repeat once again, in this particular diagram, in this particular size reduction equipment, we use an external air to transfer the smaller particles from the crushing zone from out of the system. So here the feed enters from here by means of a screw conveyor so that the dosing of m dot is constant, and we have a central shaft on which the the hammers are mounted. Okay, so this is a big sledgehammer which is mounted on it, and here we have the second one. So as the disc is rotating, what will happen? The hammers will be rotating inside a compartment, and here we try to reduce the casing here because we wanted to put a ceiling on the size of the particle, and here we have a separator vane also. Vane means what? I told you already what is a vane, which is used to control the flow rate in a continuous system. So in your air conditioner, there will be a vane will be there in front of it. As the vanes are moving, what will happen? The direction of the wind changes. If you try to close the vanes, what will happen? Air will be present inside the system. Pressure drop increases. Because of it, turbulence will be very high. The movement of the solid particles will be very high. But if you try to open it, what will happen? A jet of air goes out, and along with it, particles which can pass through this narrow gap. Remember, this narrow gap is important through which the particles will be going out. Now remember, if the size of the particle is more, it will be going from B to A. If the size of the particle is less, the particle will be coming from A to B. This is the direction. The fines will be coming from A to B. Oversized particles will be going from B to A direction. And once they go in this grinding zone, what will happen? They take the blows of this grinding, these hammers. And once the size is less, then since we are blowing air continuously, because the shaft is also carrying the fan. So how the air transportation is there? Air will be sucked into the system by means of these fans, and from the outlet they will be taken up. So there are additional fans are there here, which will be rotating along with the shaft. So not only the hammers are rotating, the fan will also rotate. So it sucks the air from here, and then if the size of the particle is small, what will happen? Along this gap it goes. Who will go? Air will be going along with the smaller particles, and from there through the outlet duct it goes out. So now we are supposed to keep a fabric filter or a cyclone separator to separate the small particles from the air. Air is discharged out, solid particles are taken out. So this is how the crushing is taking place inside this micro atomizer. Yeah, fluid ice energy mill also cutting is there. Yeah, this is a very important diagram where this is also from the examination point of view very important, where the particle sizes are very small. But remember, we are supposed to consume huge amount of energy. High pressure air or high pressure steam is sent from the bottom, and these are the energizing nozzles, because whenever the fluid is moving from higher cross-section area to narrow cross-section area, its velocity increases tremendously. When the velocity increases tremendously, we are in a zone of high turbulence. When the turbulence is there, what will happen? The currents will be moving in zigzag fashion. And as the currents are moving in the zigzag fashion, what will happen? If you introduce the solid particles, they will also start moving in the different directions. And because of interparticulate attrition, the size reduction will take place. So inside this, in a fluid energy mill, the size reduction will take place only because of interparticulate attrition. That is important. So here we have a closed loop will be there, a pipeline will be there in the form of elliptical these things, and then what will happen? The feed will be sent from means of this conveyor belt. It falls into the hopper, and slowly by gravity they will be coming down. But here a part of the feed is diverted by means of this pipeline. It is sent into the venturi. So what will happen? Because of this venturi effect, what will happen? The velocity of this air or the steam increases tremendously, and that induces its energy to the particle which is moving slowly. It gains momentum, and then it moves in this guided fashion, and then it strikes the surface. Size reduction takes place, and immediately, since we have the air, a major part of the air or steam in this particular section, it starts moving in this particular fashion. Since it is a pipeline which is guided one, all the solid particles or the steam will be moving in this particular fashion, and because of the high turbulence, they will be moving in a zigzag fashion, and then the size reduction takes place because of that. And one more thing here is, as you try to see this point and this point is toward the center. So particles whose sizes are small, they will be concentrating along this line. The particle whose mass is more, that will be concentrating in this particular line. So if an attempt is made to remove the particle, so we should take out a outlet from only this particular line. So here if you see, we are having an outlet from this particular line. So what will happen, because of the energy of the system, with this narrow gap, what will happen, along with the fluid, even the solid particles will also go out without any suction or anything else. Automatically the opening leads that these high pressure gases goes from this particular opening along with the particles which are concentrating along this line. Which particles are those? Particles whose masses are very less. So they go out from the system. Again, you can have a cyclone separator or a filter, fabric filter. We can separate the solid particles from the air or the steam, which can be recycled back, or we can send a fresh air or the steam. So this is the example of a fluidized energy mill where the crushing will take place because of interparticulate accretion. So this is the diagram of a colloid mill where ointments and pastes are made like this, where we add the active ingredient in a quinol base and then we send it from the left hand side with a high pressure, and then in a casing this rotor will be rotating and this rotor will be having a variable area. So initially we will have more area, but as it tries to come from the back, the area will be decreased. So hence this will be used. This creates a high shear forces on the materials through which it is passing. So as the materials are passing through this narrow gap, high shear forces will be induced. So any size reduction will also take place, fine particle size reduction will also take place, but at the same time distribution of the ingredient in the large base will also take place in this, and from the left hand side the material comes out, we can collect it and then tube it and then send it back. So the breaking the agglomerations, especially in the paint industries, where grouping of particles are taking because of the reduction in the electrostatic forces, that can be suspended again, that can be mixed properly, and then the paint can be sent out from the bottom. So here, this is the example of a colloid mill where the feed is made to pass through a narrow gap, and this rotor disc which is rotating with high RPM induces very high shear forces because the casing is not rotating, whereas the disc is rotating. Because of it, high shear forces will be generated and small quantity of size reduction takes place, but here our main aim is to mix the material thoroughly. Sugar syrups or agglomerations can be broken in this. Okay, this is the diagram of a rotary knife cutter where we have a central shaft here, and then to the central shaft which is driven by means of electrical motor. It carries the disc, and the disc is of this fashion, which will be having the provisions for the knives to be accommodated. So these knives are connected by means of these nuts and bolts. So here in this diagram, if you see 1, 2, 3, 4, 5, 6 are there, and in the theory we have seen that the knives will be varying from 2 to 12. And here we have the bed knives which are fixed to the casing of the system. So when the knife is coming in between this gap, there will be a narrow gap will be there. When the feed comes in this narrow gap, it will be cut into pieces, and if the size is small, it will be passing through the clear opening, or else this knife will do the extra work of cutting the particle, because the accumulated materials where it will go, sir, it will be collected in this narrow gap, and in this narrow gap what will happen, these knives which are moving with a higher RPM, they will be coming and they will be cutting the particle, and if the size of the particle is less, then only it will pass through the screen, it passes from the bottom, or else it will stay inside this accumulated part, accumulated gap. Why accumulation? Because you are sending feed continuously, and then if the particle is not going out, they will be accumulated in this particular volume, and again these knives will be acting on them to tear them into pieces. So that is how the crushing takes place, and the particle comes out from the bottom. So these two bed plates, so here we have a screws. So if you try to rotate this, the bed knife will be going in this fashion, it comes up, so that we can control the size of the gap clearance. So when you reduce the size, then we get a smaller particle, and when this is going this side, we can get a particle of bigger size. So here the reduction takes place because of cutting. Only one equipment is there. So rotary knife cutter, since only one equipment is there, coming in the examination, we will be having a greater chance. Yeah. So, yeah. So these are the major types of the equipments which are there, and then we had a second revision also, and then you know what are the importance, because the diagrams which you can draw it in 15 minutes or 5 minutes, that will only come in the examination. So now let us see what is the total flow sheet. That is, as I said, that it is not possible to get lumps of solid particles in a single equipment. So we are supposed to use a hierarchy of size reduction equipments, and then to increase the efficiency of the machine, we should have a proper recycling techniques, etc., etc. And this diagram will tell us how it is happening, and hence the name is called as flow sheet for closed circuit grinding. And there is an open circuit grinding is also there, and this is the closed circuit grinding. So the feed initially comes from this point and then goes out from the bottom. So the feed, when it comes, it goes to the gyratory crusher. Then in the gyratory crusher, the crushing will take place, and we have a mixed particles product which is obtained, that is subjected for the sieving. So here we have a first sieve. So what will happen? Some particles will pass through it. So some particles will not pass to the second sieve. So these particles are all coarser particles which are again recycled back to the main gyratory crusher. Whereas some particles which are passing through the second screen also, now their sizes are intermediate. So now they are sent to the rod mill. See the diagram of a rod mill, the cylindrical part is more, since it will be carrying a grinding medium of rods. And in the rod mill, how the size reduction takes place? When the rods roll over one another, size reduction takes place. Here we need not lift the rods to a greater heights and from there allow them to fall. It is not possible, because robustic construction of the rods and power consumption will increase tremendously. So hence the rods will be rolling over one another. If the compressive strength of the material is less, instead of rods we can replace it by means of the tube mill. That is the only difference between tube mill and the rod mill. Shell is same, but the grinding mediums are different. So in the rod mill, what will happen? We keep the rods, and then the intermediate particles are sent to this rod mill, and then the rod mill also rotates slowly. So as the rods are rolling over one another, the size reduction will take place, and the product is taken out from here. Now the solid particles which are passing through the third sieve also, they are told as fines. These fines on the outlet of the rod mill, now they are sent to the ball mill, where in the ball mill further crushing will be taking place in presence of water. Remember this. So here in this ball mill, we are going to send the water, and then we are going to control the wide fraction, and then after the crushing is over, it is now sent to a centrifugal classifier. A classifier is a device which is separate the feed into two fractions. One part liquid and heavier particles, second part liquid with smaller particles. Remember once again, a centrifugal classifier is a device which separates the feed into two fractions. The feed is what? Solids plus liquids. Solids plus heavier solids are sent into one particular section. Solids plus smaller sizes will go in a separate section. So if you see the centrifugal classifier, one feed is there, water plus solids. Then here we have waters and fine products are going out, whereas water and heavier solids, they come from here. Again we add makeup water from here, it is sent back to the system. So oversized particles are sent back. So now here this is subjected for drying and then takes place. Now one more condition is that we can add water provided the feed is inert to the water. If the feed is not inert to the water, again we have a problem of the reactivity. We cannot add any water, but we should go for conventional dry crushing in the ball mill without using the water. And if you want, you can keep separately one more equipment called as fluidized energy well if the consumer dictates lesser sizes. So if you see this entire flow sheet, we have a feed from here and the product is going out, but in between it is passing through a hierarchy of equipments to reduce its sizes. So hence it is called as closed circuit grinding. Okay. So in the open circuit grinding, of course, we add the feed from here, then feed will be coming out, and then it is sent to some other machine. So in this closed network, feed enters, product goes out.